we're going to dive into an exciting programming language that's been gaining a lot of traction in the tech world, Rust. Whether you're a seasoned developer or just getting started, Rust has something valuable to offer you, so let's go. So, why Rust? Well, Rust is a systems programming language designed to help you write fast and reliable software. One of Rust's standout features is its ability to combine high-level ergonomics with low-level control. This means Rust makes it easy to write safe, expressive, and high-level code by offering rich standard libraries, powerful syntax, and comprehensive error messages. At the same time, it provides the tools needed to directly manage underlying hardware, such as memory, when performance and control are critical. This unique balance is one of Rust's key strengths, setting it apart from other programming languages. Now, is Rust meant for you? Let's start by comparing how Rust benefits students and professionals. For students, Rust is an excellent choice for learning systems programming concepts. Here's why. First, you get educational resources. You're provided with comprehensive documentation, which is accessible for new learners. Next up, the community support. The Rust community is known for being welcoming and helpful, providing support through forums, chat rooms, and mentorship programs. Then we have practical learning. So Rust's focus on safety and performance helps students understand important programming concepts such as memory management, concurrency, and system-level programming. Now, for professionals, Rust offers significant advantages too. Professionals can greatly benefit from Rust's features. First up, reliable code. The compiler enforces strict safety checks, reducing the likelihood of bugs and making code bases more robust and maintainable. For performance, it's comparable to C and C++ and is perfect for high-efficiency applications. Also, it provides you modern tooling with tools like Cargo for dependency management, Rust Format for code formatting, and Rust Analyzer for IDE integration. This enhances productivity and streamlines development workflows. Many leading companies have adopted Rust for its reliability and performance. For example, Mozilla. Now, Rust was originally developed by Mozilla for performance-critical components of their Firefox browser. It's also used in Dropbox, where they use Rust for parts of their file storage backend to improve performance and reliability. Coursera implements Rust for their data processing pipelines, benefiting from Rust's efficiency and safety. Figma updated their multiplayer synchronization engine from TypeScript to Rust to improve performance because their server could not keep up with the user growth. Microsoft integrates Rust into their systems programming for safety and performance improvements. So whether you're a student eager to learn or a professional seeking reliability and performance, Rust is meant for you. It offers a powerful toolset that caters to a wide range of needs and applications. In this, we'll be exploring Rust's key features that set it apart from other programming languages. If you're new to these concepts, don't worry, we'll break them down step by step. We'll also go into more detail in later parts of the course. Now, Rust is designed with the focus on safety, performance, and concurrency. Here are some of its key features. First up, let's talk about memory safety. Now, one of Rust's standout features is its unique way of managing memory safely without needing a garbage collector. This is done using a system of ownership with rules that the compiler checks at compile time. The main concepts are ownership, where each piece of data in Rust has a single owner. Then there's borrowing, where references to data can be created, but these references do not own the data. Then you have lifetimes. These ensure that references are always valid. Next, let's discuss concurrency. Now, this means writing programs that can do multiple things at the same time. Concurrency can be tricky because multiple parts of your program need to access the same data safely. With Rust's ownership model, it ensures that data is accessed safely by multiple threads, catching potential issues at compile time. This makes it easier to write safe and efficient concurrent code. Another key feature of Rust is performance. Rust is designed to be as fast as languages like C and C++. It gives you low-level control over how memory and other resources are used, which is crucial for writing high-performance applications. Despite this control, Rust safety features help you avoid many common programming errors. Rust's philosophy can be summarized as safe and fast. It provides you the safety of high-level languages with the performance of low-level languages. This means you can write code that is both efficient and free from many common bugs that plague other systems programming languages. So, what is Cargo? Cargo is the package manager and build system for Rust. It helps you to manage your Rust projects, handle dependencies, run tests, and much more. So you can think of it as your all-in-one tool for Rust development. Now, why do we need Cargo? First of all, Rust projects often involve multiple dependencies, and managing these manually can be error-prone and time-consuming. So Cargo automates this process, ensuring that you have the right versions of libraries and that everything compiles correctly. Now let's see Cargo in action. We'll start by creating a new Rust project. First, open your terminal and head over to your project's directory and run the following command to create a new project. So Cargo new hello cargo, it's going to create a new directory named hello cargo with a basic Rust project inside. Now navigate into this directory with cd hello cargo command. Inside this project directory, you'll see a source folder with a main.rs file and a cargo.toml file. The cargo.toml file is where you define your project's metadata and dependencies. Let's open the cargo.toml file in a text editor. The cargo.toml file is in toml format and it includes sections for package metadata and dependencies. It looks something like this. This file helps Cargo manage your project by specifying its name, version, and Rust edition. The dependencies section lists any external libraries that your project needs. Now open src/main.rs and you'll see a simple hello world example. So Cargo has already generated this program for you, placing the code in the source directory and the configuration in cargo.toml file. To build your project, you're going to run the following command in the hello cargo directory. So cargo build command compiles your project and places the executable in target/debug directory. To run the executable, use the following command. Either this ./target/debug/hello cargo, or you can just simply run cargo run command, and this command compiles your project if there are any changes and also runs the executable. Cargo also provides the cargo check command, which checks your code for errors without producing an executable. For example, let us change our code. So over here, we've missed a semicolon. And if we do cargo check, it will check our code for any mistakes. And this is faster than cargo build and is useful for quickly verifying your code as you write it. So over here, you can see that it tells us that the semicolon is expected but is missing from our code. Cargo is a powerful tool that simplifies Rust development by managing dependencies, building projects, and running code efficiently. With simple projects, Cargo doesn't provide a lot of value over just using Rust C. but it will prove its worth as your programs become more intricate. So once programs grow to multiple files or need a dependency, it's much easier to let Cargo coordinate the build. In this, we're going to write a very first Rust program. So let's get started. First, let's create a new file for a Rust program and we'll call it main.rs. So remember, Rust files always end with the .rs extension. If you want to use more than one word in your file name, underscore to separate them, for example, hello underscore world.rs instead of hello world.rs. Now open the main.rs file and write the following code. So this is a very simple program that prints hello world to the screen. We have our main function that does not take any parameters and does not even return anything. It's a special function because it's the entry point of every executable Rust program. The function body over here is wrapped in curly braces, and inside the main function, we have a single line of code that's printing hello world. So over here, println is a macro and it's not a function. So you'll know it's a macro because of the exclamation mark. Macros in Rust are powerful tools that can generate code at compile time, and we will learn in detail about macros later. So when you run the following program, it gives you hello world on screen. Also, one thing to note is that in Rust, semicolons are very crucial as they differentiate between expressions and statements. So it's important to be conscious of their use to avoid unexpected behavior. As we move forward in this course, we'll understand when and how to use semicolons correctly to ensure our code behaves as expected. Now let's save the file, compile, and run a program. So open your terminal and navigate to the directory where you saved your main.rs file. And we're going to write rustc main.rs. We already know what does this command do. So this command uses Rust compiler to compile your program. And after compiling, you'll have an executable file named main. To run a program, you're going to enter the following command. Now, regardless of your operating system, you should see hello world printed to your terminal. So let's quickly review what we've learned so far. We wrote a simple main function, used the println macro to print a string, and compiled and ran a program using the terminal. So these are fundamental steps to writing any Rust program. Now, if you remember, we studied about cargo in the last module. While just compiling with rustc is fine for simple programs, as your project grows, you'll want to manage all the options and make it easy to share your code. And that is where we're going to use cargo in the future modules. So before we wrap up, here's a quick exercise. Go ahead and create a new project using cargo. Write your hello world program and build it. And to keep your code consistent and well formatted, you can use the Rust format tool, which is included with the standard Rust distribution. Just run rustfmt and provide the name of your file. Just run rustfmt main.rs and it's going to automatically format your code. In this, we'll be learning about comments in Rust. So comments are a crucial part of writing clean, understandable code. So let's dive in. First, let's define what comments are. So comments are lines or blocks of text in your code that are not executed by the compiler. They are used to explain and document your code, making it easier to understand for yourself and others who may read your code in the future. So comments in Rust are very similar to those in other programming languages. They are used to explain what your code does, which can be extremely helpful for anyone reading your code, including future you. Let's look at how to write comments in Rust. First up, we have single-line comments. The single-line comments in Rust start with 2 forward slashes, and everything after these 2 forward slashes on that line is considered a comment and is ignored by the compiler. So let's go ahead and add a few single-line comments to our main.rs file. And as you can see, we have added 2 single-line comments, one above the main function and one above the println macro. And these comments over here are going to explain what each part of the code does. Then we have multi-line comments. The Rust also supports multi-line comments, and they're useful when you need to write longer explanations or even temporarily disable blocks of code. Multi-line comments start with /* and end with */. Let's add a multi-line comment to our code. Notice how the multi-line comment spans several lines, and each line inside this comment block starts with an asterisk for readability, but that's optional. The Rust compiler will ignore everything between /* and */. Let's look at some of the best practices for comments. Number one, they help you to enhance code readability. So use comments to make your code easier to understand for others and future you. Keep your comments clear and concise. Avoid unnecessary explanations or redundant information. Focus on context, not the obvious. So comments should explain why decisions were made, not describe what the code does. Highlight key insights. Use comments to note important details, edge cases, or non-obvious logic. Let's understand what is mutability. In programming, the concept of mutability refers to whether the value of a variable can be changed after it has been initialized. If yes, the variable is called a mutable variable, whereas if the value of a variable cannot be changed after it has been initialized, it's called an immutable variable. In Rust, variables are immutable by default. This means that once a value is bound to a variable, you cannot change that value. Rust encourages immutability to help ensure safety and concurrency in your programs. So let's see what happens when we try to change an immutable variable. When we try to compile the code, we'll get an error because we're attempting to change the value of y, which is immutable. This error message over here tells us that we cannot assign a new value to an immutable variable. This compile time check helps prevent bugs by ensuring that values remain constant when expected. While immutability is the default, there are situations where you need a variable's value to change. So in Rust, you can make a variable mutable by adding the mute keyword. Let's modify our example to make y mutable. Now with the mute keyword, the variable y can now be reassigned. When we run this code, it compiles and runs successfully, allowing y to change from 10 to 20. So using the keyword is useful when you need to change a variable's value, but it also signals to other developers that the variable's value will change, enhancing code readability and maintainability. So understanding data types is crucial because Rust is a statically typed language, meaning it needs to know the types of all variables at compile time. Let's get started. So every value in Rust has a specific data type that tells the compiler what kind of data it's working with. And Rust data types can be broadly categorized into two subsets, scalar and compound. And we're going to start with scalar data types. First, let's talk about scalar types. So a scalar type represents a single value. Rust has 4 primary scalar types: integers, floating points, booleans, and characters. Let's start with integers. So an integer is a number without a fractional component. And Rust provides several built-in integer types, which can be either signed or unsigned. Signed integers can represent both positive and negative numbers, while unsigned integers can only represent positive numbers. Here's a table of Rust integer types. By default, Rust uses the i32 type, which is a 32-bit signed integer. But you can specify other types if needed. Here are some examples of integer literals in different formats. First up, we have a decimal, which is a base 10 number. Then we have a hexadecimal number, which is base 16 and is prefixed with 0x. Then we have an octal number, which is a base 8 number, a binary number, which is of base 2, and is prefixed with 0p. And then you simply have a byte literal, which represents the ASCII value of the character A, that is 65. And this is of type U8. When we print it, we get our corresponding integers. Next, we have floating point numbers, which are numbers with decimal points. So Rust has two floating point types, F32 and F64. The default is F64 because it's more precise. Boolean types in Rust are straightforward. They can be either true or false and are specified using the bool type. And booleans are primarily used in conditional statements, which we'll cover in another video. Lastly, we have the character type, char. Rust's char type is 4 bytes in size and represents a Unicode scalar value, meaning it can represent more than just ASCII character. Here are some examples. As you can see, it can even represent an emoticon. Now, let's move on to compound types, which can group multiple values into one type. So Rust has two primitive compound types, tuples and arrays. Tuples can group together values of different types into a single compound type. Once declared, tuples have fixed length. Here's how you can create and use tuples. First up, we'll start with tuple declaration. Over here, we have created a tuple tube with 3 values of types I32, F64 and U8. Then we're going to destructure the tuple. So over here, we have variables x, y, z, and the tuple is broken into x, y, and z, and y is printed at 6.4. We can also access tuple elements using index. So elements are accessed directly by using dot notation, such as tub.0, tub.1, and tub.2. Tuples are useful for returning multiple values from a function. Arrays, on the other hand, are collections of values of the same type. Arrays in Rust have a fixed length. Here's an example of creating and using arrays. The indexes of an array start with 0 and go till length -1. Here's a scenario. You have an array and you want to access an element by its index. But what happens if the index is out of bounds? Let's explore this with an example. In this example, we have an array with 5 elements. This means that the index goes from 0 to 4. And we are trying to access element at index 6. This code compiles successfully, but let's see what happens when we run it. So when you run the program using cargo run, this is what happens. The program panics and exits with an error message. Rust checks at runtime to ensure the index is within bound. If it's not, Rust will panic to prevent accessing invalid memory. This is an example of Rust's commitment to memory safety. Rust's memory safety principles ensure that your program doesn't access invalid memory, which could lead to unpredictable behavior or security vulnerabilities. Instead of continuing with an invalid memory access, Rust stops the program immediately. To handle invalid array element access gracefully, you can use methods like get, which returns an option that you can match on to check if the index is within bounds. Here you can modify the example to handle out-of-bounds access safely. It is okay if you do not understand the code here, because we're going to dive into all of these topics later. So today we covered the basics of Rust's data types, including scalar types like integers, floating point numbers, booleans, and characters, and as well as compound types like tuples and arrays. Understanding these data types is fundamental to mastering Rust. In addition to immutable and mutable variables, Rust also has constants. So in Rust, constants are similar to immutable variables, but with a few key differences. Constants are values that are bound to a name and they're not allowed to change. They are always immutable and are declared using the keyword const. Unlike variables, constants must have their type explicitly annotated. For example, over here we have const max users equals to 1000. In this example, max users is a constant with a value of 1000. The U32 type annotation indicates that this constant is an unsigned 32-bit integer. Now, constants are perfect for values that should never change and are used throughout your code. And using a constant makes your code more readable and easier to maintain. Let's see some differences between constants and variables. First, you can't use the mute keyword with constants. Constants are always immutable. Second, constants can be declared in any scope, including the global scope. This makes them useful for values that many parts of your code need to know about. For example, the server address. Another key difference that constants may only be set to a constant expression, not the result of a value that could only be computed at runtime. Let's see an example of a constant expression. Over here, we have 3 constants, and the calculation over here is done at compile time, ensuring that the value is fixed and cannot change during runtime. Rust has a naming convention for constants, which is to use all uppercase letters with underscore between words. This makes constants easily distinguishable from variables. For example, max score, pi, and default timeout are all good constant names. Let's look at some of the benefits. First, they make your code more readable by giving meaningful names to fixed values. They help prevent magic numbers, which are hard-coded values with no explanation. They also make your code easier to maintain because you only need to update the value in one place if it ever changes. In this, we'll be exploring a fascinating feature in Rust known as shadowing. Shadowing allows you to reuse variables' name in a way that can make your code cleaner and more understandable. Let's dive in and see how it works. Shadowing in Rust allows you to declare a new variable with the same name as a previous variable. The new variable overshadows the old one, making it accessible only within a certain scope. This can be very useful for using variable names without needing to introduce new ones. In this example, the variable a is shadowed twice. First, it's incremented by 1, and then within an inner scope, it's multiplied by 2. When the inner scope ends, a returns to its previous value, which is 6. Let's see why should we use shadowing. First, it allows us to reuse variable names without mutability. It provides flexibility to change variable types and helps keep your code concise and readable. For example, in the code here, the variable spaces first holds a string and then its length as an integer. This flexibility simplifies the code and helps avoid the need for additional variable names. Let's look at the differences between shadowing and mutability. It's important to understand the difference between shadowing and mutability. With mutability, the type of the variable must remain the same. However, with shadowing, you can change both the type and the value of the variable. With shadowing, you create a new variable each time you use let, and it allows you to change the variable's type and value without making it mutable. Shadowing is particularly useful within different scopes. Each time a variable is shadowed, the new variable is only valid within its scope. So once the scope ends, the previous variable is back in effect. For example, over here, the number is shadowed within an inner block. But outside of the block, the original number is still accessible. And hence, when you print the following code, it'll tell you that the number in outer scope is 10, while the number in inner scope will be 20. Let's look at a practical use case where shadowing can make your code cleaner. Imagine you're processing user input and need to convert it to different types. In this example, we read user input into a string. Then we trim any white space, shadow it again, and then we convert it into an integer and shadow it again. So this approach keeps our code concise and readable by reusing the same variable name, which is input in our case. So in this video, we explored shadowing in Rust, which is a powerful feature that allows you to reuse variable names and keep your code clean. We learned about the benefits of shadowing. its difference from mutability, and how to use it effectively within different scopes. Today, we're going to dive into one of Rust's most powerful features, macros. Macros help you write cleaner, more efficient code by allowing you to define patterns that can be used to generate code. Macros in Rust are a way of writing code that writes other code, which is known as metaprogramming. They are used to reduce boilerplate, implement domain-specific languages, and much more. Macros come in two main types, declarative and procedural. We'll start with declarative, which are the most common. Declarative macros are defined using the macro rules keyword. Let's look at a simple example of a macro that prints out a greeting. So in this example, we've defined a macro named greet that prints hello crustaceans. To use this macro, we call it with a greet. And when you run this code, the macro expands to the println statement, which then prints the greeting. Macros can also take arguments, by the way, making them even more powerful. Let's modify a greet macro to accept a name as an argument. The name and expression statement over here is the pattern that the macro matches when it is invoked. Here, name is a placeholder for the input that the macro expects, and expr means that the input must be a Rust expression, such as a variable, a literal, or a more complex expression. The expression is a type of fragment specifier that tells the macro what kind of input it will receive. So when you call greet macro with Alice or Bob arguments, it prints out hello Alice and hello Bob respectively. Now macros are incredibly useful for reducing boilerplate code, implementing domain-specific languages, and generating repetitive code. Here are a few practical use cases. First, we have logging macros. And these macros are used to simplify logging throughout your application. This is just an example of how you can do it. Next, we have something that we've been using all this time, which is the println macro. And it's used to print text to the console. It's similar to the print functions you might have used in other programming languages, but as a macro, it offers more flexibility and power. Control flow is a fundamental concept in programming that allows you to dictate the execution path of your code based on certain conditions. For example, consider a program that determines whether a number is positive, negative, or zero. Depending on the value of the number, different blocks of code will be executed to provide the correct output. In Rust, control flow is managed using conditional statements like if, else if, and else. In this video, we'll walk you through these control flow structures, provide detailed explanations and examples to make it easy to understand. First up, let's start with the if statements. The if statement is the most basic control flow statement. It allows you to execute a block of code only if a condition is true. This is how the syntax looks like. You have the if keyword followed by the condition, and then there's some code that's supposed to be run if this condition evaluates to true. Let's look at an example. In this example, the condition that the number should be less than 10 evaluates to true because the number is 7. So if you run this code, you're going to get the output that the number is less than 10. Next, we have else statements. The else statement provides an alternative block of code to run if the condition in the if statement is false. If you look at this example, you have a number that's initialized to 15. We have a first condition that says that the number should be less than 10, and it's false because the number is 15. So the code inside the else block is going to run, and we're going to get our output that the number is 10 or greater. Now let's look at the else if statements. So the else if statement allows you to check multiple conditions in sequence. Once a condition is found to be true, the corresponding block of code is executed and the rest of the conditions are skipped. So in addition to the if statement, you can use multiple else if statements to specify more conditions. Let's look at this example. Over here, you have a number that's initialized to 20. You have one if block, one else if block, and one else block. For the first if condition, it asks that the number should be less than 10. it will evaluate to false. Then you have that the number should be less than 20. It's also going to evaluate to false. And in the end, the else block is going to run, which is that the number is 20 or greater. Now you can combine multiple conditions using logical operators like logical AND or logical OR to create more complex conditional statements. For example, over here, you have a number variable which is initialized to 25. There's this first if condition which asks that the number when divided by 5 should have the remainder 0 and the number when divided by 2 should also have the remainder 0. Only if both of these conditions are true, the if block is going to execute, and 25 when divided by 2 will not give the remainder 0. So the if block will evaluate to false. Then you have the else if condition that the number when divided by 5 should have the remainder 0, which is true. And hence the else if block is going to execute, giving us the output that the number is divisible by 5 but not by 2. Now, in Rust, if statements can be used to assign values to variables. This is particularly useful for concise conditional assignments. In this example, the variable number is assigned the value 5 because the condition true evaluates to true. If the condition were false, number would be assigned the value 10. So if you're going to run this, the output will be that the value of number is 5. Here's a summary of what we've covered. First, if statements, they help you execute a block of code if a condition is true. Else statements, they provide an alternative block of code if the if condition is false. Else if statements, they check multiple conditions in sequence. Combining conditions, you can use logical operators to create complex conditions. And then you have using if in a let statement, which lets you assign values conditionally. In this video, we'll look into loops and labels. So looping allows you to execute a block of code repeatedly. And Rust provides several looping constructs including loop, while, and for. The loop construct is unique because it repeats indefinitely until we stop it with a break statement. Let's look at the syntax of how a basic loop looks like. You have the loop keyword followed by curly braces, and then there's the scope where you have the code that is going to run indefinitely. Let's look at this example. So over here, the loop is going to print the line that this will run forever indefinitely. So until you stop the program, it's not going to terminate. And this is how the syntax will look like if you want to add a break statement. Break out of the loop, you can use the break keyword, and you can use the control structures like if, else if to specify the break condition. Let's look at this example. So over here we have a loop that's running and it's incrementing the count variable and printing its value. But when the count reaches 5, the break statement is executed, terminating the loop. And this is how the final output is going to look like. You can also return values from a loop by using the break statement with a value. This loop will terminate and the value will be returned. So over here in this program, the loop increments count until it reaches 10. And when the count equals 10, the loop terminates and returns count, which is 20. So this returned value is stored in our variable result. As you can see, let result equals to loop and it starts the loop and then it returns back count into 2, which is 20. So it's going to give you the output that the result is 20. Now, in Rust, you can label loops to give them a name, which is useful when you have nested loops and need to control which loop is used to break or continue from. This is how you can label your loop. So you give them a name, which is useful when you have nested loops and need to control which loop to break or continue from. They are defined with a single quote followed by the label name. In this example, we have an outer loop named single quote outer and an inner loop which does not have a name. The inner loop is going to run until the variable inner count reaches 2. However, if the outer count reaches 3, we use the break outer statement to exit the outer loop, and this will break the entire outer loop. The final output is going to look something like this. So on each iteration of the outer loop, the inner loop will run twice since it breaks when inner count equals to 2. And this will continue until the outer loop is explicitly broken when outer count becomes 3. In Rust, the continue statement works similarly to how it does in other languages like C or Python. It is used to skip the current iteration of a loop and immediately jump to the next iteration without completing the remaining statements in the current iteration. For example, over here, we have a for loop. It's okay. We'll see the syntax of for loop in the next video. This for loop goes from the value 1 to 5, and if the value is 3, it skips the iteration. So it will not print the number is 3 because it's going to skip the entire loop body. So over here, we get the output that the number is 1, the number is 2. With the number is 3, it was skipped, so we do not get it on the output. We get the number is 4 and the number is 5. Now, understanding loop, labels, and returning values from loops in Rust provides you with powerful tools to control the flow of your programs, especially when dealing with complex nested loops and needing to return specific values. Here's a summary of what we have covered. First up, basic loop. It creates an infinite loop that continues until a break statement is encountered. Then we have loop labels. They help you name loops with labels to control which loop to break or continue from in nested loop scenarios. Next up is break and continue. Use break to exit a loop and continue to skip to the next iteration and combine them for more control. Returning values from a loop. You can use the break statement with a value to even return value from a loop. Rust provides several looping constructs, including for, while, and loop. This video focuses on the for and while loops, which are commonly used to iterate over collections and repeat code based on conditions. First up, we have the for loop. The for loop in Rust is used to iterate over a collection of elements such as arrays, vectors, ranges, and iterators. This is how the syntax looks like. You have the for keyword followed by a temporary variable, in keyword, and then the name of your collection. Then there's code to run for each element in the collection. Let's look at the example. In this example, the for loop iterates over the numbers array, printing each number. So it's going to give us the output. The number is 1, 2, 3, 4, 5. You can also use the for loop to iterate over a range. You can use a range to create a sequence of numbers to iterate over. In this example, the for loop iterates over the range 1 to 6, which includes the number 1, 2, 3, 4, and 5, but 6 is exclusive, and you get the respective output. The while loop in Rust repeats a block of code as long as a specified condition is true. This is how the syntax looks like. You have the while keyword followed by the condition. Let's look at this example. Over here, the while loop continues to run as long as the number is not 0. And the loop prints the current value of the number and decrements it by 1. So when the number reaches 0, the loop terminates and the program prints liftoff. So over here, we start with 3, which is not equal to 0, then 2, which is not equal to 0, 1, which is again not equal to 0, and finally, when it gets decremented to 0, the condition that the number should not be equal to 0 evaluates to false, and we come out of the loop printing liftoff. You can also combine multiple conditions using logical operators like AND and logical OR to create more complex conditions. In this example, the while loop runs as long as the number is less than the limit and the number is even. The loop prints the current value of the number and it increments it by 2 in each iteration. So we get the following output. First, the number is 4, then it gets incremented by 2. So it becomes 6. Then it gets incremented by 2 again and it becomes 8. And the next time it gets incremented by 2, it becomes 10. But the number should be also less than the limit, which is 10. So it breaks out of the loop and it prints that the loop terminated with number 10. So you can use the break statement to exit a loop early and the continue statement to skip the rest of the current iteration and start the next iteration immediately. In this example, the for loop breaks when the number is 5 And it skips even numbers using the continue statement. So only for odd numbers, it's going to print the line number followed by the number itself. Let's look at the output. So as we can see, it started with 1, printed it, skipped number 2 because it's an even number. Then we got 3, printed it again, skipped number 4, and finally broke out of the loop at number 5. We can use the same example with the while loop also. So the only change here is that instead of a for loop, we've used the while loop. So first we created a variable called as number, and the condition in while is that the number should be less than 10. So you get the same output even while using the while loop. So understanding for and while loops in Rust provides you with powerful tools to control the flow of your programs and process collections of data efficiently. Here's a summary of what we've covered. First up, we have the for loop, which is used to iterate over a collection like arrays, vectors, and ranges. You can also iterate over a range, so you can use ranges to create sequences of numbers to iterate over. Then we have while loop, which repeats a block of code as long as the condition is true. You can also combine condition in while loops using logical operators to create more complex conditions. And using break and continue, the control loop execution can be broken using the break statement or can be skipped using the continue statement. Pattern matching with the match statement in Rust is a powerful control flow construct that allows you to compare a value against a series of patterns and execute based on which pattern matches. This video will provide a detailed overview of the match statement, explaining how it works and providing examples to illustrate its usage. The match statement in Rust is similar to switch statements in other languages, but it's much more powerful. It can handle a variety of patterns including literals, variables, wildcards, and more complex patterns like tuples and enums. Using match, we can write concise and expressive code that clearly expresses your intent. Let's look at a basic match statement. So the basic syntax of the match statement involves specifying a value to match against using the match keyword and a series of patterns to compare to it. So each pattern is followed by a block of code that it executes if the pattern matches. Let's look at this example. In this example, the value of the number is compared against the patterns 1, 2, 3, and then you have the default option. Since the number is 3, the code prints 3. Now, in Rust, the OR operator is used to specify multiple patterns in a match expression. It allows you to match multiple values to the same arm of the match block. This is helpful when you want to execute the same logic for multiple possible values. For example, something like this means that this arm matches if number is 1, 2, or 3 and prints the number and prints the line that the number is 1, 2, or 3. Let's look at this example. In this example, the value of number is compared against the patterns 1 or 2 or 3. And since a number is 2, it's going to print the line 1, 2, or 3. You can match ranges of values using 2 dots and an equal to. So in this example, the value of number is compared against the ranges 1 to 5, which means it's between 1 to 5, or 6 and 10, and then this default. So a number 7 lies in the range 6 to 10, and hence we get an output as between 6 and 10. You can also use match to destructure complex data types like tuples, structs, and enums, allowing you to extract and work with their individual components. In this example, the tuple pair is destructured into the components x and y. The first pattern matches if x is equal to y. The second pattern matches if x and y are opposites. And then we have a default condition. So over here, 2 and -2, these are opposites, and hence we get the respective output. Sometimes you may not need to use all the values in a pattern. In that case, you can use the wildcard to ignore values. So over here, the underscore is used to ignore the y component or the second part of the tuple, which is 8. So we get that the first number is 2 if you compile this out. Now, pattern matching with Rust provides a powerful and flexible way to control the flow of your programs. Here's a summary of what we've covered. First is the basic match statement, which compares a value against multiple patterns and executes code based on pattern matches. Then we have matching multiple patterns using the OR operator. We learned how to use ranges to match range of values. Then you can also destructure with match, so you can extract and work with components like tuples, structs, and enums.